Hello, welcome. Today let's try to solve another Leetcode problem. 14, 16, restore the array. So basically, we need to know two values. So one is s, so s is a string, but inside it is represented by digit numbers. So it can be from 0 to 9. Yeah, and also we have a k value. So this means we need to split the string s, but inside it will be numbers. So the numbers should be in the range of 1 to k. And this k, let's check the maximum of k should be 10 to the power of 10. And also, this length of the string is 10 to the power of 5. Yeah. And we need to return a value of modular 10 to the power of 9 plus 7. So this is a prime number. Basically, we need to modular by this number. Yeah. So for this problem, I'm going to use the DFS plus memorization to solve it. So let's first check an example. So why this is 1? Because for this one, only 1000 meets the condition. 1000 is less than this k, 10,000. But if we split from here, 10 with 0, 0, it's gonna return false. So this is also described in the description. So it means we cannot start with a 0. If we start the number with a 0, we're gonna not count it as 1. We just need to count it as a 0. So it means we have to use 1000. So for example, yeah, even we can use 1000, but 1000 is more than 10. But we cannot use the 10 with 0 and 0. And for this one, in total, there are 8. I'm going to give this as example in the whiteboard. After that, I will go to the code editor to finish the coding. So let's first go to the whiteboard. Yeah, now let's see the whiteboard. I'm going to use the third example. It will be 13, 17 as this one. So basically for this one, I'm going to check I'm going to search it using DFS. So for the DFS, I'm going to search it one by one. So for example, if I take so the DFS will start from 0 index. So 0 is an index of the string s. Yeah, so it means it will start from here. So for the DFS, so I can take this one, so I can slice it. I can slice the one first. If I take this one, so what left behind? It is the 317. If I take 13, for example, I will slice from here. I have a 13, and what's left behind? It is 1 and 7. If I take 131, what's left behind? It is a 7. And if I take 1317, what's left behind? It's an empty string. Yeah. Basically, for my checking, if I get an empty string, it means I take 4 numbers, I get an empty string. So I will count it by 1. So this is for my DFS. If I get a solution, I will count it as 1. I will count how many of them. But this DFS will be very large according to the length of the string. It can be 2 to the power of, it can be 4 to the power of, 10. Yeah, basically we cannot, it may become even a large number, but we're gonna use the memorization to save the steps. Let's just check one by one. So for here, 317, we can go from this, take 3 out, and we have 17. Take this 31, we're gonna have a 7. Take 317, so we're gonna have an empty string. So if I find an empty string, I just need to plus 1 because I find a result. But there are some duplicate. Let's see if we can find a duplicate. Let's say this 17. So here, for this 17 here, and here is another 17. So for this 7, I can take 1 left behind is 7. If I take 7 left behind is empty. For an empty string, I will code it as 1, and for 7, I can take 7 out, and left behind is empty string. I will code it as 1. So 1 plus 1 equal to 2. So for here, I don't need to check it anymore for the DFS. I just need to get a 2 because I will use memorization for this place, for this 1 and 7. Yeah, so actually this place is for index 1. So because 1 and 3 is index 1. For 1, it is index 0. So for index 1, I gonna have a result of 2. So for here, I will get a result of 2. And here, I got a result of 1. And here is 1 and 1. Here, also 1 and 1. So in total, it will be 8. I will got a result of 8. So there are some other conditions. For example, if we have a 0, for example, we have a 1, 0. So we're gonna split it as 1 and 1, 0. For 1, what left behind? It is a 0. So if we have a string inside it is a 0, we just need to return false, because according to the description, our numbers cannot start with 0. If we can start with 1, so if we take a pen, what left behind is empty string. If we find empty string, so we're gonna just return it because we find 1. So we just need to return 1. And how to check this condition? It's also easy. We just need to check the index. If this index equal to the length of the string is n. Yeah, if this index equal to the length of string, it means the string is empty. So we just need to return a 1. Yeah. Now let me go to the code editor to finish the coding. And we also need to check the numbers for each of the step. We need to check these numbers if it is less than 2000, less than or equal to 2000. If it is more than 2000, so for example, maybe there's a 1317 with 4, maybe there's other numbers. Yeah, this is more than 2000. We just need to break it. We don't need to go for the DFS. We don't need to call for the DFS anymore. We just need to break it. Yeah, it means we're gonna not search from here. Yeah. Now let me go to the code editor to finish the coding. So I'm going to prepare a mod because we are going to return a modular of this number. So the mod should equal to 10 to the power of 9 plus 7. And I'm also gonna define a variable n. So n is the length of the string s. Yeah, before I'm going to define DFS, I'm going to use a case just for saving the time. Otherwise, it will be time limit exceeded because basically it's a DP problem. We have to use a case. So we need to define a DFS function. Inside, I'm going to have an index. Now I will give a path first. So for calling the DFS, I'm going to just return this DFS with 0. So I'm going to start from the 0 index of the string. Now I'm going to check the conditions. So if this index equals to n, it means I need to find a result. So I can return a 1. Otherwise, I'm going to loop through the string. So for I in range, while I'm loop through the string, I need to start from the index. From the beginning, the index is 0. Maybe for the next time, the index is 1 or 2 or 3. So this is according to the DFS. So for here, the index started from 0, and for here, the index start from 1, 2, and 3. Yeah, so for here, the index start from 0. But here, the index start from 1, because this is 3, the index is 1. And here, 1, 7, the index is start from 2, and this is 3. Yeah. If it is start from 4, we just need 2 plus 1, get a result. Yeah. So I need to loop through from the index to the maximum of the number. I need to, the length of the string, basically. Now I'm going to check it. So if this index, so if this number equal to 0 string, if it is equal to 0, it means I need to break it. I don't need to count it. I don't need to call for the DFS function. Or if this number from the index to I plus 1, because in Python this is not included, so I need to I plus a 1. So this is, for example, the index is 0, and this I from the beginning the index is 0, the I is equal also 0. So this 0 plus 1, it means I gonna have the first character. For example, I gonna have a first number with 1. Yeah, I'm gonna check this number. If this is a 0, I just need to break it. Or if this number is more than k, I just need to break it. Yeah. Yeah, maybe we're gonna have a very large number. It is more than k. Just we need to, yeah, break for the coding of the DFS. Now, if we are safe, we just need to accumulate the result. So before accumulating, I need to define a variable result. So this result should plus the other situations. It would be DFS I plus 1. So for each one of them, it will be I plus 1. And finally, I just need to return the DFS modular the mod. Now let me just run it to check if it works. Yeah, let's check if there are some other bugs. So this is a non-type and int. Yeah, because here I need to check it, otherwise it will always be break. So this one should be more than, if it is more than the number k, more than this value, I need to break it. Now let me run it again to check if it works. Yeah, because here I need to turn it into an integer. I just forget about it. Now let me put it inside to check again if it is okay. Yeah, I also forget to return the result, because basically for this case I need to use a result. I forget to return. Yeah, because I'm define a result. So for each of the index, I need to return this result and then put this result into my case. Now let me run it again to check if it works. Yeah, as you can see, it works, but like this way, it cannot pass for the Leetcode. Let's just try to submit it. And by the way, this is just their ON time complexity. This n equals to 10 to the power of 5. Yeah, this cannot pass. It is memory limit exceeded because we used a big number. Because for this DFS, basically this is a very large number. And for this coding of the DFS, for each of the result, it is a very large number. If we use always be the very large number, it is stored inside the Python, inside the memory. Yeah, inside the memory, I think it is for a number, it is inside the stack. We cannot store too much numbers. It will become a memory limit exceeded. Yeah, and then we cannot use a modular here. Before we use modular to the final result, we should use modular to this return. Yeah, because only in this way, for each of the result, it would be a very small number. Otherwise, this number will be 10 to the power of 100 or 200, because in Python, it can be a really big number. Yeah, now let's just run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass for all the testing cases. Yeah, I'm sorry. I think the numbers is stored inside a heap. It's not a stack. Normally for the functions, it is stored inside a stack. Yeah, as you can see, it passed and it's pretty fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problem like this. See you next time.